Okay, our goal here today is solving equations, and our focus is getting variables on one side and the integers on the other or opposite side. So we're going to begin with the equation 9x minus 12 equals 8x minus 3. So in previous lessons we talked about drawing a wall down the middle of the equal sign, creating a barrier between the left side and the right side. Now, the important part here is to remember we always need to isolate the variable, meaning get the variable by itself. The only way to do that is to move the variables to the other side of this wall or the equal sign. And when we discuss this, and the way to do this is to always perform the inverse. The inverse of a positive 8x is a negative 8x. What we do to one side of the equal sign, we must perform the same thing on the other side in order to keep the equations balanced. And here, inverses always cancel. 8x minus 8x is 0x. Now let's take a look at why we move the 8x over. It's always best to move the 8x, or in this case, best to move the 8x over because it's the smaller variable. That's a good rule of thumb. Always move the smaller variable to the other side. And the reason for this is because if you do that, then you'll eliminate the possibility of having to deal with negative variables, which you can deal with, but it's not always the best option to go that way. So back to the problem. 9x minus 8x is 1x. We're just going to bring down the minus 12, the equals. That's also why this wall is valuable, to help you remember to bring down the equal sign each time. Now, don't forget here, you have this sign in front of the 3. You must bring that down with it. It's part of the problem. Now, as you can see, we isolated the variable here. We got the variable by itself. Now we need to get all of the integers on the other side. So again, in order to make that happen, in order to get the 1x by itself, we see that this 12 is in the way, this negative 12. So to move this to the other side, we can't just move it over and write negative 12 on both sides. We need to always perform the inverse in order to move that across the barrier to the other side. The opposite of negative 12 is a positive 12. And what we do to one side, we must do to the other side to keep the equation balanced. Inverses always cancel, leaving you with 1x equals. Now take a look at this, an integer question. Just like we talked about, same sign or different sign. Here they're different, so we use our integer rules. Remember that the rules are same sign and add and keep, different sign like here, subtract. When we get 9, take the sign of the higher number. In this case, 12 is higher than 3, so we take the sign of the higher number, so it's a positive 9. We can also write this as just x equals 9. We do not need the 1 in front, but if you have the 1, that is perfectly acceptable. Okay, now we're going to look at another question similar to the one we just did. Okay, so let's say that we have x minus 12 equals 3x plus 12. Again, we always want to start this question off the same way by drawing a wall down the middle of our equal sign to separate the left side from the right side. The reason for this, again, is to keep our work organized and to also remind us that we cannot just move terms to the other side of the equal sign without performing the inverse. So remember, we need to always begin by looking at our variables. And remember, the goal here is to isolate or get the variables by themselves on one side. And remember, we talked about how do we know which variable to move over first? We should always move the smaller variable over first. In this case, what's smaller, 1x? Notice I'm putting a coefficient in front of the x, a 1x or a 3x. Of course, 1x is smaller. We're going to do the inverse to move it to the other side. we had a positive 1x, the inverse is a negative 1x. What we do to one side, we must do the same to the other to keep the equation balanced. Inverses always cancel. Now we can bring everything down. Do not forget the sign that goes along with the 12 here. It's a negative 12 equals, and now we can perform here. We have 3x minus 1x is 2x. Bring down our plus 12. Now, I know this may look uncomfortable because now the variable is on the right side, and traditionally your teachers have made it so that the variables end up on the left side. That's okay. We can use something called the commutative property of equality, which allows us to take the equation and essentially flip it. All we're going to do is rewrite it. So now we're going to take the right side and we're just going to rewrite it on the left side. Remember, if you're doing this, it's like copy and pasting on the computer. We're going to right click, hit copy, right click, hit paste. It needs to look exactly the same. Same thing here. Instead of the negative 12 being on the left, now we're going to write it on the right side of our equation. So essentially the equation's still the exact same, it's just rewritten. So now our variable is on the left, and we're more comfortable solving it this way. Now again, we isolated our variable. Now we want to get all of the integers to the other side of the equal sign. And we can do that by performing the inverse. So the inverse of positive 12 is a negative 12. And what we do to one side, we must do that same thing to the other to keep our equation balanced. Okay, now inverses always cancel. Now we look at this integer question. And we use our rules again. Same sign or different sign. We have the same sign here, so let's use the rules. Same sign, add, and keep. So we have the same signs, so we're going to add them, and we're going to keep the sign the same. Same sign, add, and keep. Bring what's left down. Remember, division should always be your last step when solving equations. Here, technically, when you have a number touching a variable, this means multiplication. So the way we get x by itself here is to do the opposite of multiplying by 2, which is dividing. And what we do to one side, we must do the same thing to the other. So if we divide the left side by 2, we must also divide the right side by 2. Inverses always cancel, and we're left with just the x equals, and we have 24 divided by 2 is 12. A negative divided by a positive is a negative. Now let's say you have a problem with dividing or multiplying negatives and positives. Look what you can use, the special triangle. We have a negative divided by a positive. You can just cover up the two signs that you have, and we have a negative left. It works every time. Again, you have a negative and a positive. This only works for multiplying and dividing, but it works every time. A negative divided by a positive is a negative. Cover signs that are given, whatever sign's left is the sign you put. So our answer here is x equals negative 12. That is it for this particular session.